Hi there. In this video, we're going to be talking about the circle. The circle is a very important shape in mathematics. It helps us to make a lot of relationships. Now, in this video, we'll be talking about the geometry of the circle, some properties that are found when the circle is intersected by some lines. Obviously, you know of the diameter. You also know of the radius, I'm sure. And you know that the diameter is 2 times bigger than the radius, or the radius is half the diameter. These properties are very useful in circle geometry, but there are others that are very useful. These are some of them. This is Z Online School. In this video, you and I are going to be answering Mathematics Paper 1 and 2 questions on circle geometry. By the end of this video, you will be able to analyze circle geometry problems very well. And after you analyze them, you'll be able to use these properties to answer questions. At the end of this video, we've got bonus tips for you. Make sure you watch this video till the end to get the maximum value out of it. The first question is coming from Mathematics Paper 2 2016 GCE Q3. In the diagram below, ABCDG is a circle with the center at O. We've been given an angle there which is 21 degrees. GBD is equal to 21 degrees in the question. Then they're telling us BC and CE are tangents to this circle at the points B and D, as we can see. There's obviously some more information, but the next thing is them just asking us questions. What I want you to notice here is that we're going to be using this property of the triangle where we have this angle here being twice the angle on the circumference. So if you look here, you can see that there, this is the center, so this other angle, it should be twice because that's one of the properties in circle geometry. Right from the start, you should be able to recognize that we're going to be using these properties that have been shown on screen. Most of our questions are going to be using these properties. Apart from this, since usually in our questions we'll be having some triangles and things like straight lines, you should also be able to remember that the sum of interior angles of a triangle is 180. You should also be able to know that the straight line is 180 degrees. These 3 things are going to be very helpful when we're answering questions on circle geometry. We have already said this is the rule this is the property we're going to be using. Now it's just a matter of calculation. So the angle GOD is equal to twice the angle GBD. Therefore, GOD is twice 21 degrees. And therefore, GOD is going to be equal to 42 degrees. Now, we're supposed to calculate angle GFE. What I want you to pay particular attention to is the triangle FDO. So we're going to be using triangle FDO. If we draw that triangle, it looks something like this. We've got point F there, we've got D, and we've got O. What I want you to notice is that at D, if you look in the diagram, we've got a tangent. Therefore, the angle CDO, or the angle ODF, as we have in this diagram here, is going to be a right angle. Hence, it's 90 degrees. Why do we say that? We know that the normal and the tangent make an angle of 90 degrees. Now, we were from calculating angle GOD. If you look carefully, in this triangle we've drawn here, G is somewhere here. And there's a smaller triangle that has been formed. So we've got G somewhere there. So the angle FOD and GOD are the same angle. So here we've got a 42 degrees. Now the question asks us to find the angle GFE, which is just the angle missing here. I'll indicate it in green like that so it's very easy to identify. This is the angle we're supposed to find. Now, if you look, we've highlighted that we're using the triangle FDO. Therefore, to find angle GFD or GFE, because if you look carefully here, there's another point formed which they're calling E. So we need to realize that the angle GFE is equal to the angle OFD. Once you realize this question becomes very easy. So to calculate GFE, we're just going to say, we're going to use the sum of interior angles of a triangle. We know that if we add the angles F we also add the angle DOF, and we add the angle OFD. We're supposed to have 180 degrees. And remember, GFE is equal to OFD. Actually, we can just put this as a note since this is like we're learning. So we're supposed to note that GFE is equal to OFD. Meaning, where we have OFD, we can just simply replace GFE. And then we'll move this DOF to the right side and the FDO to the right side. So we're going to be left with OFD is equal to 180 degrees minus the angle FDO. FDO is 90 degrees, you know how we got it. And then DOF is equal to the 42 degrees we were just from finding. And so if we punch this on a calculator, the value it gives us is the angle GFE. 180 minus 90 minus 42. That gives us 48 degrees. And here we know that OFD is the same as GFE, so you can just say GFE. If you change your angles like this, make sure you've included this note somewhere. GFE is equal to AFD. Then you can do this here that I've done where I've put different angle here. In short, what I've done is I've used different letters to represent the same angle and then use the actual letters that were used in the question. The next question asks us to find the angle GED. How are we going to do that? Well, look in this diagram very well. I want you to notice where we can find this rule that I'm going to draw on screen. As you can see on screen, I've shown you a certain property in circle geometry. If you look in the diagram and try to see where it's applied, you are going to see that the angle EAD or DAE is equal to 21 degrees. So after we note that this is equal to 21 degrees, we're going to be using triangle DAE or ADE to make it sound a bit better. So we're going to be using triangle ADE. And if you look at triangle ADE, it looks something like this. I think we can move that a bit, the bottom here. We've got A here, we've got D, and we've got E. Notice that at D we've got a tangent. Therefore, the angle that's at D here is 90 degrees. It's very important to always remember what's making us say this angle is 90 degrees is because the line DA is passing through the center of the circle at O. If this line wasn't passing through the center at all, DA wouldn't have been a normal. Therefore, the angle at D wouldn't have been 90 degrees. But because it's a normal, it's 90 degrees. We've just found out that the angle at A here is going to be 21 degrees because of this rule that I've shown you on the screen here. These two angles are in the same segment, so they're going to be equal. Now, we've been asked to find the angle GED. So G is here. The angle here can be represented in two ways. And so we're supposed to note that the angle we've been told to find, which is GED, is equal to the angle that is being formed in this triangle, angle AED. So if you know this, then we can just start calculating like we just did again. This angle here is going to be found using the sum of interior angles of a triangle. So we can say the angles AED plus the angle EDA plus the angle DAE are going to give us 180. Then we make AED the subject. After we make AED the subject, we know that all these other angles are going to cross over to the right hand side. Then we're going to replace them with the actual values. EDA is the angle here at D, which is 90 degrees. DAE is the angle at A, which is 21 degrees. Then we find the value, and we have the angle AED. This is 69 degrees. Now remember that we earlier said the angle AED is the same as GED. So GED is going to have the value same as AED. And we have answered this question. The next question is a Mathematics Paper 2, 2015, question 3. In the diagram below, a circle with center O passes through the points Q, U, S, and V. TP and TR are tangents to the circle at the points Q and S respectively. Angle VQO is 20 degrees and angle QVS is 60 degrees. It's very important when you're given a question in circle geometry, you analyze it a bit before you begin. Whenever you are answering a question, it's good that you have a pencil nearby. You just start marking out angles that you think are easy for you to find. For example, in this question, I know the angle here is going to be 120. And if you look carefully, since we've got tangents TP and their tangent points are at Q, and for the other tangent TR, the tangent point is S, you know that this angle here is going to be 90 degrees. So you can just put a small symbol like that for you to know. So you can do something like this. As you get to the end of this video, you'll be able to complete most of the angles in any diagram. But there's no point for you to find all the angles in a diagram and then just start solving them if they haven't even been asked. So just do something simple that is very visible from the first glance and then continue to find the questions. In the first question, we've been asked to find angle QUS. Now, from our diagram, I want you to focus on the shape I've highlighted in green. This shape is called the cyclic quadrilateral. What that means is that it's a four-sided shape in a circle. Now, when we have a four-sided shape in a circle, we should pay close attention. Have they given us any angles? Of course, we've got a 60 degrees here. And Apart from that, we've got some labels here. We've got Q, we've got U, S, and V. Notice that we were asked to find the angle that is situated at this point here. Now, for any four-sided shape that is in a circle, in simpler terms, or to say shortly, a cyclic quadrilateral, the opposite angles in that cyclic quadrilateral are going to add up to 180. So when I add the 60 and the angle at U here, I'm supposed to get 180. Therefore, when I'm doing my calculation, I can easily find QS, because QUS added to the angle which is opposite it is going to give me 180. Obviously it's in degrees, and then we calculate the value of QUS. QUS is going to be the difference between 180 and the angle QVS, that is 60 degrees. This was a paper 2 question, so there's no problem if you use the calculator, but you can also do these calculations usually just with your mental math skills. 18 minus 6 is going to give us 12, and then we have a 0 there, which gives us 120 degrees. This is the value of QUS. Next, we want to find the value of VQP. So look carefully in the diagram. We're trying to find angle VQP. I'm going to highlight which part of the diagram we're going to focus on. This is the part of the diagram we're supposed to focus on. What we're supposed to remember is that they told us, if we look, TP is a tangent at the point Q, and then we have this point here which touches the center of the circle, point O. Then we've got V. We've been given the angle VQO, the angle here. They've told us it's 20 degrees, and now they're asking us to find the angle here. That angle is being referred to as VQP. Now, notice here, there's a normal and a tangent. OQ is a normal, TP is a tangent. The angle between a normal and the tangent is 90 degrees, so I can show that this is 90 on the other side, and because this is 90, we expect the other side also to be 90. Therefore, the sum of the angles VQO and VQP are supposed to give us 90 degrees, because they're adding up to 90. So VQ plus VQO. These two angles are supposed to add up to 90. In mathematical terms, we will say these angles are complementary. When we find the difference, it's going to give us 70 degrees. This is how we can find VQP. Next, we're going to be finding angle PTR. We've looked at a question where we had to find a similar angle to PTR. So what I want you to do is pause the video and try this question right away and see if you can find this angle. If still after pausing the video you couldn't find the angle PTR, don't worry. By the end of this video, you'll be able to find it. What you're supposed to do here is isolate, forget about some lines that are not useful, and let's focus on what's here. We've got a point Q there of tangency, we've got S, we've got T. Actually, PTR, they've just extended these lines, so let me just do that. We can extend the lines from these tangents here, so they are passing through like that, and this one here is also passing through like that. Then we can have the points P here, the point R. Notice this point here is the center of the circle, and this point here is V. We've been given the angle at V, which is 60 degrees. And what else have we been given? We've been given the angle at 20 here, but I don't think that will be very helpful for us in this question. What we are supposed to realize here is that the angle at O, because of this property that we looked at earlier, I'm sure you can remember it, the angle at the center here should be twice the size of the angle on the circumference there. So we know now that the angle here is going to be 2 times 60, which is 120 degrees. Now if we look earlier in this video, I think in the first question we looked at the angle here plus the angle here is supposed to give us 180 degrees. Therefore, PTR plus the angle QOS is supposed to give us 180 degrees. Therefore, if we make PTR the subject here, we can find the value. We've got 120 there. We can forget about the zeros here. We can just say 18 minus 12, which is 6. Then we add the zeros that were there. Just add 1, by the way. And therefore, PTR is equal to 60 degrees. In this question, it can be also very helpful to note that the angle QTS is equal to the angle PTR. It's very important to note this because as we are using the properties of circles and lines that are cutting through these circles, we are not using a property that is linking the points P, T, R and the point O. We have just realized that PQT are on the same line, RST are also on the same line, and then we have found that on this line PT, we've got this point Q, which goes to the center of the circle, and on this line RT, we've got a point S that also touches the center of the circle. And here we form a quadrilateral. This quadrilateral has got tangents, and then we know that relationship in circle geometry that the angles that are opposite here are going to add up to 180. So this here is very important. It's what makes everything possible. If PQT and RST were not on the same line or were not collinear, we wouldn't have done what we've just done. Next, we're asked to find the angle reflex SOQ. What do they mean when they say reflex? When we have angles, they've got many types. We've got angles that are less than 90 degrees, which are known as acute. They usually look like this. We've got angles that are equal to 90 degrees, which look like this. Usually they have this small symbol here. We call them right angled angles. We've got angles that are greater than 90. Usually they'll be past a certain line here that is 90. These angles are called obtuse. Then we've got angles that are greater than 180. So if we extended this line, you can see that the angle here is greater than 180. These angles here that I've shown you at the end are the ones that we know as reflex angles. So what they're asking us here is go to the angle at SOQ, and when we look at the diagram, they're asking us to find the angle that is bigger than 180 at the point SOQ. Remember, we found the angle at point O just as we were finding the previous question. So this is not a difficult thing. You can actually answer this question by yourself right now. So we know that SOQ is equal to twice the angle QVS, which means SOQ is twice 60 degrees. and hence SOQ will be 120 degrees. From our description of angles, this 120 degrees is an obtuse angle. Now we want the reflex value of SOQ. Therefore, the reflex value is going to be equal to 360 minus 120. When we do this calculation, we should get 240. You can see most of these calculations are not very difficult. That's just the same as 36 minus 12. If you know your 12 times table, you know that it's 24. Then we put back the 0 that was there, and we have 240. If you can really notice, whenever we have a reflex angle, we should have an obtuse angle. When we have a right angled angle, we should also have a reflex angle. When you have an acute angle, we always have a reflex angle. The reflex angle plus any other angle should add up to 360. So if we have 90, the reflex angle of 90 should be a certain number that when we add to 90 will give us 360. In the next question, we're asked to find the length ST. We've been given that OS is 3 centimeters and OT is 15 centimeters. Here I'm just going to copy the diagram so that it can be easy to follow. Our diagram looks something like this. We've got S, Q, the points of tangency. We've got T, the point where the two tangents are meeting. We've got O, which is the center of the circle. I like putting a nice small dot at the center so that I can always remember. That's an indication in my mind that that's a center. And then we've been given distances. OS is 3 centimeters, so we've got a 3 here. Okay, now notice this angle here is 90 degrees, therefore we have a right angled triangle. Working with right angled triangles is very easy. Remember I said when we're looking at questions in circle geometry, we should realize it's not only circles they're going to be asking us about. Most of the times there will be a lot of triangles. Like you can see here, we've got a question about triangles. So if you don't know anything about triangles, it will be very difficult. This side here is 3 and we've got 15. It's very good for you to notice that this 15 here is our hypotenuse, and this one here is just any of the two sides, which is not the hypotenuse. To find this other side, we can label our hypotenuse as A squared, and since this one looks like our base, let's label it as B, and this one as C. We know our Pythagorean theorem. We know that the square of the hypotenuse is equal to the sum of the square of the other sides. Then we make B the subject. We plug in our numbers. A is 15. C is 3. Remember, we've got squares there. Then we've got also a B squared on our left hand side. Then B squared will be equal to the square of 15. The square of 15 is 225 minus the square of 3, 9. If we find the difference here, it should be 216. And then B is equal to the square root of 216. This is going to give us 14.7. Remember, we had centimeters, and I've already rounded off my answer to 3 significant figures. Remember, this question is a paper 2 question, so you had the freedom to use a calculator. In most paper 1 questions, when you're given a question where you're asked to find the distance, you usually be given a perfect square. You won't have a case where you have an answer that is inexact. The next question is a mathematics paper 1 2017. Note that the following questions that are going to now be answered are paper 1 questions. Therefore, make it the practice not to use a calculator because your paper 1 questions are not going to allow you to do that. In the diagram below, A, B, C, D, E, and F are points on the circumference of a circle. Angle FBD is 70 degrees and angle AEF is 20 degrees. The first question is asking us to explain why AD is the diameter. Again here, we want to use properties in circle geometry to prove that AD is a diameter. If you think about the properties that we have in circle geometry, I think the best property that can help us to prove that AD is a diameter is one that involves a semicircle. If you pay attention to your properties, there's one property that makes use of a diameter. When we have a semicircle like this, and then we have a triangle in this semicircle, the angle here is always 90. This is only true if, let's say, a distance AD is the diameter. If it's not the diameter, this rule won't hold true. In this rule, any triangle we draw that is going to be on this arc here is going to have 90 degrees here. So if this was point C, this was point E, angle ACD, angle AED are going to be 90 degrees. So what we want to do to explain here is verify if we can find the 90 degrees maybe here, or we can find that this angle here is 90 degrees. Take a look at the diagram and see if you can find a way of proving that the angle ACD and the angle AED are both 90 degrees. If you took some time to look at this diagram, you begin seeing that they didn't give us this 70 and this 20 for no reason. Because if you look carefully in this diagram, this 20 degrees here is in the segment that is the same with this angle here. If you look, we've got this angle here and this one here. These angles are going to be equal. Therefore, here we've got a 20 degrees. And if you look at this 70 carefully, let's follow it. It's in the same segment with this angle. Therefore, the angle that is going to be here is 70 degrees. Now, 70 plus 20 gives us what number? 90, right? In your explanation, you want to involve those things that we've pointed out. We've pointed out that the angle at ACD is 90 degrees after we do the calculation. And therefore, because that angle is 90 degrees, AD is the diameter. After we have given that explanation, we're asked to find ACF and DEF. If we look in our diagram, we can easily find these angles. Let's begin with ACF. Remember, this was an angle that we already found. It helped us to prove that AD was the diameter. Without much thought, we can easily find this angle. ACF is equal to 20 degrees. In the next question, we're asked to find angle DEF. Pay particular attention to the angle we have been asked to find. Angle DEF. What I want you to do is look at the diagram on screen. If we label it, we have D, E, F, and so we're required to find the angle that is situated here. Then we have C. If you look carefully in the diagram, you notice that, of course, if we add this angle here, the angle at C and the angle at E, we're supposed to have 180 because DEFC is a cyclic quadrilateral. Therefore, angle DCF plus angle DEF are going to add up to 180. Hence, DEF is going to be equal to 180 degrees minus DCF. We don't have the angle DCF, so that's why we need to think once more. Now, let me add more things to this diagram so that you can see how we can calculate DCF. From the diagram, we recognize that this point here is A. We know that AD is the diameter. We are sure that AD is the diameter. We've just explained why it should be the diameter. Therefore, the angle here is supposed to be 90 degrees. Therefore, we can indicate it's 90 degrees using this symbol here. Hence, we have to find the angle here. But if you look in the diagram, we already have that angle. The question told us angle AEF is 20 degrees. And we already have established that since this is 20 degrees and this angle AEF and ACF are in the same segment, we can conclude that this angle here is 20 degrees also. Now, we know that the sum of this angle and this angle will give us 90 degrees. Therefore, DCF is going to be equal to 90 minus 20. If you want here, you don't even have to calculate DCF. You just have to recognize that the 70 and angle DCF are the same. Then we can subtract it from 180. Therefore, DEF is equal to 180 minus 70, which is going to give us 110 degrees. This method is quite a bit longer, but if you look particularly in the diagram here, you can easily see that FBD is equal to FCD, or the angle that we said is DCF, because these two angles are in the same segment, and therefore you don't have to do any calculation. You just need to go straight from this step here, which we said DEF is equal to 180 minus DCF, and you just have to plug in 70 there. But we can also do this simple calculation here and still get the same answer. In an exam situation, you should find the shortest route possible. The next question is a Mathematics Paper 1 2019, question 16. In the diagram below, A, B, C, D, and E are points on the circumference of the circle with a center O. DE is equal to AD, ACB is equal to 20 degrees, and AOE is equal to 80 degrees. The first question is asking us to find the angle ADE. Locate ADE and look at the angles that we have been given and find a way that we can find it. Obviously, it's not very difficult. We have been given the angle here, which is 80 degrees. We have a point D there. E, we want to find the angle that is situated here. And we know that the angle on the circumference there will be less than the angle that is at the center here. Using that relationship that we've used already, we know that the angle AOE, which has been given, is twice the angle ADE. If we do some simple algebra here, we're going to find out that ADE is equal to the angle AOE divided by 2. Performing that simple calculation, we can find that ADE is equal to 40 degrees. Next, we're asked to find the angle DAE. If you look in the diagram, DAE is in the triangle ADE. So we can start from there. We look at triangle ADE. Notice they've given us very important information. They told us that the side DE, we've got D there. These two sides here are the same length. Notice that we're just from finding the angle ADE. And so it's very easy for us to find the angle here, which is DAE. This is an isosceles triangle. Therefore, the two angles here at the bottom, which are called the base angles, DAE and DEA, are going to be the same value. Let's label this angle as X. Therefore, this angle here is also going to be X. Angle ADE plus 2x is going to be equal to 180 degrees. Remember, this is a triangle. $2x will therefore be equal to 180 minus ADE. We want to find the value of x. We're going to divide both sides by 2. You can see the 2's there cancel out. So x is going to be 180 minus ADE, which is 40, divided by 2. Notice this is a paper 1 question. Refrain from using the calculator, because if you get used, you won't have it in your exam. What you can do is forget about the zeros at the end there. Just say 18 minus 4, which is 14. And then we put back the 0, which is going to give us 140. And then we divide that by 2, which gives us a 70. Remember, we said each of these angles here are going to be x. Therefore, angle DAE is equal to 70 degrees. Since we know that x is DAE or DEA, we can say, therefore, DAE is equal to 70 degrees. Next, we're going to find the value of BAD. If you look in the diagram, BAD is the angle at A. Try to pause the video and find this angle. Let's focus on this part of the diagram. We've got the point here E, D, we've got C there, B, and A. Notice that we have been given the angle at point C. The angle ACB is 20 degrees. So this angle here, as you can see in the diagram, has been labeled as 20 degrees. Now, this angle here is in the same segment with the angle here, meaning this is also going to be 20 degrees. In short, angle ACB is equal to angle ADB. The next thing we should pay attention to here is that we have the angle ADE. We calculated it as 40 degrees. Now, we've been asked to find the angle BAD. If you look closely here, you will notice that we've got a cyclic quadrilateral ABDE. Therefore, we can easily find the angle that is situated here, which is BAE. Remember, the angle we want to find is BAD, the angle here. What I want you to notice here is that the angle DAE, which we found, is actually involved for us to have the value BAE. In short, what I want you to note here is that BAE is equal to the angle we are just from finding DAE plus the angle we want, which is BAD. Making BAD the subject, we're going to have BAE minus DAE. Now, our job here is finding the angle BAE. It's very easy for us to find the angle BAE because we know ABDE is a cyclic quadrilateral, and we know that the angles opposite each other in a cyclic quadrilateral are going to add up to 180. Therefore, the angle BAE is equal to 180 minus the angle BDE, this angle here that's opposite BAE, this one here. You can see that it's opposite BAE. Now, so we're subtracting that angle. We're going to label it as BDE. And then if we plug in the value there, it's very easy to calculate. It's just 40 plus 20, which is 60. This is going to give us 120. This is the value of angle BAE. Since we have BAE, now we can find BAD. BAE is 120. DAE, we have the value of DAE. We were from calculating it. You can remember it. If you can't, you can easily calculate it from here because we know that these two sides here are the same. Finding the difference between these two is just like finding the difference between 12 and 7, which is 5. Then we add that 1 0 that was present on both numbers, which gives us 50. Therefore, the angle BAD is equal to 50 degrees. One thing I want you to notice from this question is that most questions under second geometry will be asking you a sequence of angles that are related. So it's kind of a good thing that you notice how you can make your first answer be incorporated into your second answer, and so on and so forth. You can see that we used DAE to calculate BAD. And I think we also used ADE to calculate DAE. Most of the time, this is what they do. So if you haven't found the first question, it will be sometimes very difficult to find the last question. And when you are stuck on a question, try to see how you can use the earlier answer if possible. The next question is the Mathematics Paper 1 2015 question 20. Part B was on second geometry. In the diagram below, A, B, C, and D are points on the circumference of a circle, center O. ADE and BCE are straight lines. Angle CED is equal to 21 degrees and angle BCA is equal to 43 degrees. The first question is asking us to find the angle CDE. Let's label this diagram, starting with this point here, which is B. Then we have C, D, and this point here, which is E. If you look at the actual diagram in the question, you're going to see that there's this line that passes like that. And on line DB, we've got the center. This center here is labeled as O. The angle here is 43 degrees. And now, since DB is passing through the center, it's very true that the angle at C here is 90 degrees. Because the angle at C here is 90 degrees, and remember the question told us that BCE is a straight line, therefore the angle here is going to be equal to 180. Because there's a 90 here, there's also going to be a 90 on this other side. Or simply angle DCE is going to be 90 degrees. Remember, we're trying to find the angle CDE. The angle CDE is the angle here. If you pay particular attention to the question, you find out that they've even given us the angle at E, which is 28 degrees. Looking at this triangle, the triangle DEC or triangle CDE, we can easily find out that angle CDE is going to be equal to 180 minus angle ECD minus angle CED. If we plug in our numbers, ECD is 90, CED is 28. And then we calculate this. This is paper 1, so we want to do these calculations mentally. You can do them just as simply as this, just like we did them in primary. A 0 plus an 8 will give us an 8. A 9 plus a 2 will give us 11. 180 minus 118. Again, we do that calculation. We borrow a 1 from the 8 there. We remain with a 7. We carry a 1. 10 minus 8 is going to give us 2. 7 minus 1 gives us a 6. 1 minus 1 gives us a 0. So we can just look at that 62. And therefore, CDE is equal to 62 degrees. Next, we're going to be calculating the angle CDB. If we look in our diagram, we've been given something like this. Not all the lines have been shown here. I've removed some because I want us to focus on a certain part of our diagram. The angle at C is 43, and because it's in the same segment as the angle at D, this angle here is also going to be 43 degrees. Now if you look at this other diagram here, where we have more, we've got E, D, A, B, and C. We've got a point O there, which shows DB is a diameter. Because the point O is the center. We have a 43 from this earlier diagram that we drew, and then from the earlier question we had a 62 degrees here. And now we've been asked to find the angle CDB. In this question we want to find the angle CDB, which is the angle here. If you look, ADE is a straight line, the question told us. Therefore, this 43 plus the angle here and this 62 are going to give us 180. If you look at this angle 43 is the angle ADB. Therefore, ADB plus CDB plus CDE are going to give us 180 degrees. Remember, these angles, since they're adding up to 180, you hear them in mathematics being referred to as supplementary angles. Making CDB the subject, we can find its value. The angle CDE, which we have, minus the angle ADB, which we also have. CDB will then be equal to 180 minus CDE, which was 62, ADB, which is 43. You can find a separate piece of paper where you evaluate this. Minus 62 minus 43 is going to give us minus 105. 180 minus that 105 we found is going to give us 75. Therefore, CDB is equal to 75 degrees. In the next question, we're going to be finding the angle DAC. If you look at the angle DAC, it's very easy to find. I want you to make a triangle, or recognize that there's a triangle being formed, which is triangle ADC. We've got A, D, and C. We can easily find this angle here at C, and we can also find the angle here at D, and then we are going to find the angle at A, which is DAC. When you look in the diagram, the angle ACD can be easily found. ACD plus ACB or BCA, the one they gave us in the question, BCA, you can take it as they gave it to us, is going to give us 90. So ACD, the angle that we want, is going to be equal to 90 minus BCA. BCA is 43. So we're going to be finding the difference between 90 and 43. If we calculate that difference, it should give us 47. So in this triangle of ours, the angle here is 47. And then we have to calculate the angle at D, angle ADC. If we look again, ADC here is an angle that is made up of two angles that we are just from finding, angle ADB and angle CDB. Angle ADB is 43 degrees, while angle CDB, which we calculated, was 75 degrees. We shouldn't worry so much, this is not our final answer. So we're going to find the sum of 43 and 75. That should give us 118. These two angles we found are very key as we are finding the angle DAC. DAC plus the angle ADC and the angle that we found ACD are going to give us 180. So for us to find the angle DSE, we're just going to make DSE the subject of the formula. What you can do sometimes is put these two in brackets, add them in advance, and then you're just going to subtract their sum. Sometimes it's faster, but there's no real rules for which steps you're supposed to follow. As long as you get the same answer, there's no problem. ADC is 118. ACD we found to be 47 degrees. We add these two numbers here, 118 plus 47. If we do the mental math there, it should give us 165. If we find the difference between these two numbers, we're going to get 15 degrees. So DSC is equal to 15 degrees. The next question is an ECZ Mathematics Paper 1 2016 GCE question 18. In the diagram below, TR is diameter of the circle with center O, QR and PS are parallel. Angle TOS is equal to 80 degrees and angle TRP is equal to 10 degrees. The first question in this question paper asks us to find the angle RPS. If we look at angle RPS, it's the angle that's located here. We're simply finding the angle at P. If we look in this diagram, the best way to find this angle is trying to find the angle at O here, because we know that the angle at P is half the size of the angle at O. So if we look in this diagram, is there any way that we can do that? Of course there is. Since we know that TR is a diameter and obviously TOR is a straight line, because they've told us the point O is the center of the circle, it makes sense that the angle that will be here on this other side of this line is supposed to be an angle that when we add up with this 80 is going to give us 180 degrees. That won't be very difficult, of course. We can find the angle ROS. Angle ROS is the angle we're finding, and we know that this angle is equal to the difference between 180 and the 80 degrees they've given us. If we find that, we can see that it's 100 degrees. Now, since we have the angle ROS, we can find the angle RPS, because we know that 2 RPS is going to be equal to ROS. And if we do our algebra here, we can divide both sides by 2. And then we can have the angle RPS. (100 divided by 2), which is equal to 50 degrees. The next question asks us to find the angle PST. If we look in our diagram, angle PST is in the segment with angle PRT. Therefore, we can confidently say that angle PST is equal to the angle PRT, because these angles are in the same segment. And from the diagram, we can see that PRT is 10 degrees, therefore PST is going to be 10 degrees also. The last question asks us to find PSO. How are we going to find this angle PSO? What I want you to focus on is the triangle TOS. From triangle TOS, we can establish the angle TSO. Why? If we look in this diagram, having that they've told us that O is the center, and we can see that T is on the circumference of this circle, the same as point S. we can make a conclusion that TO and the distance SO are both radii. Therefore, the triangle TOS is isosceles. And because it's isosceles, the base angles are going to be equal. So if we have a symbol diagram just to make it a bit graphical so that you can understand, we have got an 80 degrees here. And then we've got base angles here, let's call them X. These angles are going to be the same because the sides here are the same distance. If we make a simple relationship between these three angles, we're going to have the relationship that the sum of interior angles of a triangle, which is 180 degrees, is going to be equal to 80 plus x, which is just 2x. And if we want to find the value of x, we just need to make the 2x the subject of the formula. We can get this 80 on the left hand side, which will be 180 minus 80 is equal to 2x. Then we can flip this equation. We can get the 2x on the left and the 180 minus 80 on the right, and nothing changes. Since we know we're subtracting these, we can write their difference, which is 100. We know the 2 and the 2 there cancels. 2 into 100, x should be equal to 50. Now, this is not our final answer. This angle we found is just angle TSO. So we can label it somewhere. This 50 is angle TSO. We can just say TSO here in brackets so that you can easily identify this when revising. And then what we're going to do here is subtracting the 10 that we earlier found. In circle geometry, usually the answers you're going to be finding in order are going to be related to each other. So if you find part A, part B, there's obviously some relation with part C. We know that angle PST plus the angle PSO, which is the angle we want, are supposed to give us the angle TSO, which we're just from finding. So if we plug in some numbers here, PST, which we know is 10, TSO, which we have just found to be 50, making PSO the subject of the formula, we're going to find its value. 50 minus 10, which is going to give us a 40. The next question is a Mathematics Paper 1 2018 GCE question 13. The diagram below shows a circle with a tangent RWS. The points V, W, X, and Y are on the circle such that XYW is 44 degrees, VWY is 54 degrees, and SWV is equal to 39 degrees. Obviously, we're talking about circles, right? So we are supposed to have a circle. Apart from the circle, we need to have a tangent line. That is not a tangent, it does not touch the circle. We can do a better job by making it touch the circle like that. Now, I'm going to create a normal, which means this line is passing through maybe a center that is O. From properties of circle geometry, we know that the angle between the normal and the tangent is 90 degrees. In this question paper, you had to understand the relationship that is between a tangent line and the line that passes through the circle. This line that passes through the circle will be part of a triangle. If you've been following through this video, you know that this angle here is 90 degrees because it's a triangle in a semicircle. Now, let's take a look at what we've just drawn here. If this is the tangent R, WS, and then we have a point, let's say A here, there are some relationships that are very key that have been formed here. whenever we have an angle between a tangent line and the line passing through the circle, I want us to focus on the line AW, and I want us also to focus on this angle opposite the line AW. For any case where we have this representation that I've just drawn here, the angle that is going to be here is going to be equal to the angle that is going to be here. Now, how do you remember it? Well, if you have an angle that is formed between a tangent, you can see this line here is part of the tangent, and then we've got this line that is part of the triangle. The angle between these two lines is going to be equal to the angle that is opposite that line which is not part of the tangent. So this is the line that is not part of the tangent, AW, and then we're talking about the angle that is opposite this line, which is this angle here. So this angle here, which is, let's add a point, a letter here, let's say it's B. So the angle at B here, ABW, is going to be equal to the angle AWS. Why? Because the angle formed between the tangent and this line is going to be equal to the angle that is opposite this line which has formed an angle with the tangent. Now, if we go to our question, you're going to see that this line here hasn't passed through the center. However, this rule that we've just talked about does not only apply to lines that have passed through the center of the circle. They apply to any lines that have made an angle with the tangent. So, if we look at the angle here, you agree with me this angle here is not 90 degrees because 54 plus 39 is not giving us 90 degrees. Using what we just learned, it's very easy to establish that the angle that is going to be here is going to be equal to the angle at X. This angle here is opposite the side that has formed an angle with the tangent. Let's try using this rule in a much different way. We've got a 39 degrees here. The line here has formed an angle with the tangent. Therefore, the angle that is opposite this line has the same value as this angle here. Hence, the angle at X is going to be 39 degrees. Now, I'll ask you a question here to see if you've understood what we've been talking about. Can we do the same for this angle that is 54? Of course not. Why? This 54 degrees does not make an angle with a tangent. This line here is not a tangent. So is this line here. With this information, now we can find the angle RWX. We don't even have to worry much when finding the angle RWX because we can easily see the relationship we just talked about. This 44 degrees is the angle opposite to a line that is forming an angle with the tangent. If you look, this side here, which is opposite 44, has formed an angle with the tangent. Therefore, the angle that is formed by these two lines is going to be equal to this 44 degrees. Next, we're going to be finding the angle XVW. If we look at this angle, it's in the segment where we have the angle XYW. And the question tells us the value of that angle. It's 44 degrees. Therefore, again, we're not doing any calculations. XVW is equal to XYW. And we have the value of XYW. So XVW is going to be equal to 44 degrees. The next question asks us to find the angle YXV. If we look carefully, this angle YXV is in the same segment as YWV or VWY. The question again gives us the value of VWY, which is 54 degrees. Therefore, we know the value of this angle because it's equal to an angle that they've already given us. And that is 54 degrees. The next question is a Mathematics Paper 1 2016, question 19. In the diagram below, PR is the diameter of the circle with center O. Q and S are points on the circumference. The tangent to the circle at the point P meets QS at T. PQS is 26 degrees and QPR is 42 degrees. They've told us a lot of things here. Just make sure the information in the question is matching with the diagram, and then you can start analyzing the diagram. After you've analyzed the diagram, you can go straight to the questions. The first question is asking us to calculate PRS. In this question, you can see that the angle 26 that has been given is in the same segment with the angle that they've asked us to calculate. Therefore, PRS is going to be equal to the angle PQS. And we have calculated the angle PRS. Next, we're supposed to find the angle PRQ. If you look in our diagram, we've got the triangle PRQ. This triangle has 90 degrees in it. You can see that it's in a semicircle. They told us the point O is the center. Angle PR passes through the line PR passes through the center. Therefore, it's a diameter, which makes the angle at Q 90 degrees. In the question, we've already been given the angle at P, which is 42 degrees. And then we are asked to find the angle PRQ. We know that PRQ plus the rest of the angles in this triangle should add up to 180. And if we make PRQ the subject, we're going to have 180 minus QPR plus RQP. We have the values of QPR and the value for RQP. If we add 42 and 90, we should get 132. If we subtract these two numbers, we're going to get 48, and this is the value of PRQ. Next, we're asked to find the value of PTQ. If we look at PTQ, we notice that it's an angle formed by the tangent TP and the line TQ. If you look in this diagram, we've got Q there, T, P, we've got point O somewhere there, which is the center, we've got R. The angle RPT is 90 degrees. PRI is passing through the center, so it's the normal. TP is a tangent, and we know that the angle between the tangent and the normal is 90 degrees. We've been given a 42 degrees, the angle QPR. We've been given a 26 here. And we've been asked to find the angle PTQ, which is the angle here. What you're going to notice is that we have a triangle. In this triangle, adding up the angle PTQ plus TPR, which is the 90 degrees, plus QPR and PQT or PQS as they've said it, but here we can say it's PQT, there's no problem. The sum of these angles are going to give us 180. We don't have 4 angles in this triangle, we just have 3. This angle here is one angle, the angle that is at this vertex P. So PTQ is going to be equal to 180 minus all these other angles, TPR plus QPR and PQT. In this question, you must note that the angle PQT that we are referring to is equal to the angle PQS. Point S is the point here, so that's what makes them equal. Continuing with our working here, TPR is 90, QPR is 42, PQT is 26. And now we're going to find the difference between 180 and the sum of these numbers. 42 plus 26 is going to give us 68, and then if we add the 90 and the 68, we're having 158. So that's what we're going to be subtracting from 180, which is going to give us 22. So angle PTQ is equal to 22 degrees. You have finally reached the bonus tip section. In today's video, we want to share with you one tip that you should always remember when you're looking at psychogeometry problems. The diagrams are made to test your identification of the different problems, so you shouldn't expect these diagrams to be drawn to scale. Most of the times you find that the diagrams will be drawn such that they hide these properties. You will struggle to find the answers to certain problems until you can visually see the properties that have been hidden. Now, the solution is very simple. You just need to answer multiple questions to have experience with various manipulations. This is why in this video we answered quite a lot of psychogeometry problems. Thanks for reaching till the end of this video. Make sure you check the description for the downloadable PDF for the answers that were written in this video.